So in the previous video, we have already seen the how many questions were asked from the geography section and how important is the geography section, in which we have already seen the twisters, tornadoes, and the demographic winter that was asked. So those who have not seen the previous video can go and click on the link that is flashing above on this screen. Apart from this, this was left the cloudburst, and this is a very important static topic in the geographic section, in which we see how these cloudburst happens. And in this year question means they have asked again explain the phenomenon of cloudburst. So now when we look upon this cloudburst, we have to arrange some parameters, and these are those parameters. First is we have to define in this kind of a question. So particularly, we have to define on a geographical definition. So if you know the actual geographical definition, what is cloudburst? It is actually different from a rainfall or a precipitation. Normal rainfall is not a cloudburst. You have to remember this point. When you see a 100 millimeter per hour of rainfall in a 20 to 30 square kilometer of area. So short duration, intense rainfall in a short region is classified as a cloud burst. Now we will understand, if we don't remember that this particular definition, then we can also write about the recent cloudburst incidents that have happened in 2020 or 2021 in Himachal Pradesh or Uttarakhand. Apart from that, you can also quote the 2013 Kedarnath devastating cloudburst incident. So now we will move upon the most important part of this video, that is formation and phenomenon, that is the mechanism of cloudburst. So we know that the cloudburst happens on generally due to orographic rainfall, and this orographic rainfall is nothing that it is a kind of a rainfall that is associated with mountains. When we study different types of rainfall in geography, we have convective rainfall, we have frontal rainfall, we have orographic rainfall. So in this video we will particularize and we will point towards the orographic rainfall. So now, before going on this orographic rainfall, we will first go towards the condition of India in the month of June to July. As you know that India lies in northern hemisphere above 0 degree equator, and due to this, you know that the India in the center of India, 23.5 degree north tropic of Cancer passes, due to which ITCZ, this is ITCZ, Intertropical Convergence Zone. These are the theories that already been explained in monsoon. So I'm not going to explain here. Briefly, I can just say that this is ITCZ is nothing but this is 0 degree, and we see that these are southwest winds and trade winds, southwest trade winds. And now these southwest trade winds, when blow towards the equator from the southern hemisphere towards the northern hemisphere, due to Coriolis force effect, these winds diverge in the right hand side in the northern hemisphere and in the left hand side in the southern hemisphere. So now what will happen, this will cross this equator and become like this right hand side, and this trade winds that has just gone across the equator will now act as southwest monsoon winds that get into the Indian landmass, and it is generally bifurcated into two branches, that is Arabian Sea and Bay of Bengal. The Arabian Sea branches move from the passes in between Western Ghat towards the northern plain, and this particular uh, Bay of Bengal branch winds move towards the uh, eastern Himalayas ranges and get deflected into the northern plains. So now these trade winds actually crosses the equator. In the similar way, northeast trade winds coming towards the equator from the northern hemisphere also crosses the equator and moves like this, because in the southern hemisphere it moves like in the left direction when some wind is coming in into the southern hemisphere. So whenever these trade winds will meet at a particular region, this region is known as ITCZ. So this is a highly low pressure zone. So this will be highly insulated by the sun, because India is in front of the sun inclined at this particular time. We already know that in June, July, there is summer solstice. After this summer solstice, this is the period in the northern hemisphere where the sun rays are almost perpendicular towards India. So this IT season will create a low pressure in the northern plain. So this particular line depicts this ITCZ here. So now once you have understand why low pressure has grown in the northern plains, there is also one more point you have to remember, that India is surrounded by water from the three sides, and this water generally heats up, takes time to heat up as compared to land. So generally what happens, the same concept of sea breeze and land breeze will happen in the monsoon. So the winds will always blow from the high pressure towards the low pressure, and on the water, because this water is heated very slowly as compared to land, so there will be high pressure generated in comparison to the low pressure on the land mass. So now the wind will start blowing like high pressure towards the low pressure, towards the northern plain. And we already know that there is a mountain chain in the northern side, that is Himalayas. It runs from the Kashmir region towards the northeast region, from the western Himalayas toward the northeast Himalayas. And generally the cloud burst you will see happens at this particular region on these mountains. So now coming back on this orographic rainfall, what happens in the actual mechanism of this cloudburst and how these cloudbursts happen. So this is suppose a mountain range, and now what will happen? These winds are actually the warm winds that are having moisture with it, because these are the winds that are carrying moisture from the Arabian Sea and Bay of Bengal towards the Indian landmass, towards the mountain ranges. So these warm winds are coming like this and getting rising on this, climbing on this mountain. As this warm winds will rise, you already know, we have learned the laws of physics, that warm vapor will rise because it is lighter and the molecules inside it is loosely packed. So that will act as it will rise up, and as it rises up, this will particularly forms a cloud, and this cloud is generally formed due to the process of condensation. And in condensation process, we already know that the vapor state get converted into liquid droplets. So these warm wind will have liquid droplets accumulated in the cloud form due to the process of condensation. Now what will happen, that this is a normal situation in which rainfall occurs on an orographic rainfall in Western Ghats or wherever there is a hill mountain. This is the system in which the cloud will get formed, and finally the cloud will set its water content, moisture, because at a particular extent only this cloud will hold this particular moisture, because as this air rises up on the mountain, what happens, due to going up high altitude, what happens, generally temperature is lowered down, so and pressure is increased. So what happens, this the capacity of this particular cloud is reduced to hold this particular liquid droplets, so it's set down. So this is a normal rainfall, but here you have to think very cleverly and very sincerely what is happening in the tail of a cloudburst. Now I will tell you what is happening. Due to the supply is very increased of this particular winds, because this low pressure is created here due to ITCZ, and there is an enormous supply of this hot air winds from this branch and this branch, both branch, Arabian Sea and Bay of Bengal, towards this mountain ranges. Towards here are many mountain ranges in the Dholadar ranges, Jaskar ranges. Apart from that, many ranges are there. So now, as this air will rise up, you know that as this layer will rise up, the upper layer is troposphere. You know this troposphere is there, and this troposphere is almost 15 kilometer. But this height of the mountain is Western Himalayas mountain is 5 to 6 kilometer only. So it will not go towards the 15 kilometer, but due to cold snow sitting on the top of this mountain, there will be cold air here, so that will also try to cool down this air. But naturally this doesn't happen because the supply has increased, supply has enormously increased towards it. So what will happen, that this cloud will not shed the rainfall, and this particular cloud will go on thick, having thick layers. So this is particularly cumulonimbus cloud, a combination of cumulus and nimbus cloud, and generally thick layers will, density of this cloud will increase. As density of this cloud increase, the capacity holding of moisture content, the water droplets will also increase because the water droplets is increasing. So now what will happen? Suddenly these clouds will not allowed to go to 15 kilometer. This will sorry. This will generally what will happen that sudden due to cold snow sitting on the top of this will sudden blast, and this cloud will sudden blast, and as you know that the density of cloud was very much, and the sudden blast will happen a flash flood. It's like a burst of the flood, and this will flow down on steep slopes of a mountain. So what happens generally on a mountain? We know that there are many sediments. As these Himalayas were formed and Tethys seas sediments were there, and the small rocks, mud were there, sediments were there, this all will flow down small rocks towards the plain areas. So always cloud burst is a very devastating phenomenon because this is not happening at a plain, it is happening at a steep slope, and this will carry whatever comes in its way. So here we have seen the formation and phenomenon, that is orographic rain, uplift of air, warm air, then formation of cloud due to condensation, then increase of the cloud layers due to this supply of this warm air will increase, and sudden blast because sudden dissipation of moisture was there because these were not allowed to move upwards. So now the occurrence also we have seen that is mostly due to on the western Himalayas. This cloudburst will generally happen in hilly areas, but if question comes in prelims that cloudburst can not happen plain areas, you don't have to mark it wrong because there is no hard and cold rule for that. Also, consequences we have seen: mud flows, can happen, flash floods can happen, water sprouts can happen, even landslides can happen. Many things can happen, but these consequences can be very, very much devastating as we have seen in recent cloudbursts. Apart from that, when we conclude this particular topic that explain the phenomenon of cloudburst, we have to conclude that we cannot predict the accurate timing because this is very, very of short duration, so we cannot predict the accurate timing, but we can have mitigation measures. We can have mapping techniques. We can have radar techniques here to find the exact locations where this has happened and where there is a chances of heavy rainfall in the future. So hopefully you have got a clear gist of the topic cloudburst, the mechanism, the conclusion, the consequences, and the definition. Thank you for watching, and please subscribe.